Exceptions, or rather exception handling, is the part of the programming language that allows you to deal with problems that occur during the execution of your program. Our trusted online encyclopedia explains exception handling as the process of responding to the occurrence during computation of exceptions, anomalous or exceptional conditions requiring special processing, often changing the normal flow of program execution. In object-oriented design, exceptions are objects representing the anomaly. To see how this mechanism works, it's instructive to consider the normal flow of a program with subroutines. When your main program calls a subroutine X, it will be put on hold and the program executes X from start to finish before continuing in the next line of the main program. X itself may call another subroutine, let's say Y, so the program would continue as Y from start to finish, then re-enters X and ultimately back to the main program. This pile of temporarily postponed routines is customarily called the call stack. Nice. Now suppose deep down somewhere an error occurs and a routine fails. For example, you try to divide by 0 or try to access invalid memory or non-existing files. There are several different ways to handle this. You could either try to exclude all possible errors before you even call that subroutine Y. You could also simply ignore the error and pretend that Y was successful and continue with X as if nothing happened. Another possibility is to have Y return a special error code that indicates that it was unsuccessful and let X deal with the return code. Many object-oriented programming languages deal with such situations by having Y raise or throw what's called an exception to report that an anomaly has happened. The interpreter would then look for what's called an exception handler, so special code that deals with this situation. And if it finds one, let's say an X, that code takes over. And afterwards, X continues as if nothing happened. Otherwise, if X does not define such a handler, we further look up the call stack and so on. Exception handling is built into many, especially object-oriented programming languages. This allows to standardize error handling and a clean separation of error and normal code. To report an error situation, you create and throw a suitable exception, and to handle errors, you have to define a matching exception handler. A common code pattern looks like this. You wrap the code that may trigger exceptions, so the dangerous code, in a try block, and this is followed by one or more catch blocks that define exception handlers, one each. Now, what should you do inside this exception handler? You could either report or rethrow the exception or log and continue. This is totally up to you. It's the programmer's responsibility to say what should happen in this situation. One crucial aspect to remember is that exceptions are objects. An exception represents the anomaly with all its interesting information, such as the timestamp or the call stack at the time it occurred. As any other objects, exceptions can have attributes and methods, but they also have a type, and that is used to identify a suitable exception handler. These types of exceptions, of course, correspond to classes in a class hierarchy of different exceptions. For instance, you can have file not found, or division by 0, or array out of bounds exceptions, all subclasses of a common exception class. This common exception class could, for example, define a getTrace method, which is then inherited, and special types of exceptions, such as the file not found exception, might have other attributes, such as path, which stores the file path that was inaccessible. You can, of course, have a deeper hierarchy of exception classes. For example, you could have two different types of input-output exceptions, file not found, as well as file access exceptions. This mechanism, of course, also allows you to create your own exceptions simply by subclassing the appropriate class. Considering this, we can extend the commonly used pattern from before. Now it defines two different handlers for two different types of exceptions in line 4 as well as 7. Both are essentially methods that take an exception object as an argument, which can then be used, for instance, to access details about the problem that occurred. So for example, you could access the path attribute inside the code that deals with the file not found exception to complain to the user that a specific file path was inaccessible.